Example 10, refer to the graph below. Classify each sequence as a walk, a path, or a circuit. Write yes or no in each column on the right. So let's look at E, C, D, E. Walk, no, because we can't get from E to C without going through B. Is it a path? No, again, we can't get from E to C. It would be if we could. It had a line, an edge from E to C. A, C, C to D, D to E, E to B, B to A. Is it a walk? Yes. Is it a path? Yes. Is it a circuit? Yes. B to D, D to E, E to B, B to C. Yes, it's a walk. No, it is not a path because we used something more than once. And no, it's not a circuit because we don't start and end at the same spot. And the last one, A to B, B to C, C to D, D to B, and B to A. Yes, it's a walk. Yes, it's a path. Oh, no, it's not a path. Yes, it's a circuit. A weighted graph is a graph with numbers on the edges. The numbers are the weights. Example 11, refer to the direct bus link in example 7. And now we're planning a bus trip from Escanaba to Grand Forks. We want to know the length of time it takes the bus to travel the various routes. Find the route from E to G with the shortest travel time. We could go E, Y, M, F, G. 2 hours 40 minutes, 6 hours 5 minutes, 5 hours 35 minutes, 1 hour 35 minutes. We could go E, D, M, F, G. And that's 6 hours 35 minutes, 3 hours 15 minutes, 5 hours 35 minutes, 1 hour 35 minutes. We do need to find these totals if we're finding the shortest travel time. This totals to 15 hours and 55 minutes. This one totals to 17 hours. A complete graph is a graph in which there's exactly one edge going from each vertex to each other vertex in the graph. Draw a complete graph, with 2 vertices. Here's our picture, and there is one edge. Three vertices, there's our picture, 3 edges. 4 vertices, 6 edges. Six, 7, 8, 9, 10, and 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. A complete graph with n vertices has n times n minus 1 divided by 2 edges. Example 13. In a round-robin tournament, each contestant plays every other contestant once. The winner is the contestant that wins the most games. How many matches are there in a round-robin tournament with 24 players? There are 24 vertices. Each vertex is degree 23 because each one is playing 23 other matches. The sum of the degrees is 24 times 23. Sum of the degrees is twice the number of edges. So we do 24 times 23 divided by 2. A coloring of a graph is an assignment of a color to each vertex in such a way that vertices joined by an edge have different colors. The chromatic number of a graph is the least number of colors needed to achieve a coloring. Coloring a graph. You're going to need colored pencils or crayons to help you with this. Choose a vertex with greatest degree and color it. Use the same color to color as many vertices as you can without coloring two vertices the same color if they're joined by an edge. Choose a new color and repeat what you did in step 1 for vertices not already colored. Repeat step 1 until all vertices are colored. One of Tabitha's jobs at her college's Learning Center is to schedule study groups for the courses in the left-hand column of the table below. Study groups for different courses must be scheduled at different times if there are students taking both courses. The right-hand column shows which of the other courses have students in common with it. For example, the first row shows that each of the courses, statistics, chemistry, history, and physics, has one or more students also taking algebra. Tabitha must determine which, if any, of the 7 study groups can be scheduled at the same time, so the fewest number of time slots are used. Help her solve this problem by drawing a graph and finding its chromatic number. Starting with our graph, A for algebra, H for history, C for chemistry, B for biology, P for physics, S for statistics, and W for writing. I'm going to make a point at each of these. Algebra matches up with statistics, chemistry, history, and physics. History and statistics, history and chemistry, history and biology, and history and algebra. Chemistry and physics, chemistry and biology, chemistry and writing, chemistry and algebra, chemistry and history. Biology and physics, statistics, writing, history, and chemistry. Statistics with writing, algebra, history, biology, and physics. Writing with statistics, chemistry, and biology. I'm going to start with biology, and I'm going to put a circle around it. And are there any other vertices that are not connected to it? It's connected to history, chemistry, physics, writing, and statistics. It is not connected to algebra. I'm going to go to statistics next, and I'm going to use a triangle. You can use a different color with your colored pencils or your crayons. Statistics is connected to algebra, history, biology, physics, and writing. It is not connected to chemistry. So I triangled it. Writing, I'm going to put a square around it, is not connected to physics, so I can square it. And it is not connected to history, so I can square it. We have 3 different colors or 3 different shapes. Algebra and biology can be scheduled at the same time. Statistics and chemistry can be scheduled at the same time. And history, physics, and writing can be scheduled at the same time.